Okay, so you're ready to get into 3D printing now. But what do you need other than the actual printer to start making prints? Let's get into part 2 of Intro to 3D Printing. Hey everyone, Jason here at 3D Matter Makers, and this week we're going to be taking a look at the various software packages you can use to create your 3D prints. But first, if you like these videos and have not yet subscribed to the channel, please click that subscribe button. Clicks are free and everybody wins. Now, as I said in part 1 of these videos, the 3D printing terminology can be really confusing. Now, last week we covered the primary parts of the actual printer itself. But this week we need to talk about the other half of the printing process. Now again, these are just the basics to get you started and are by no means a definitive guide on 3D printing and software. So having said that, let's get right into it. There are a few basic pieces of software involved in 3D printing. First is some sort of 3D modeling software like Fusion 360, Tinkercad, ZBrush, Meshmixer, or any other similar 3D modeling software. You don't need any of these to be able to 3D print, but if you want to create your own designs or even modify other people's designs, then you will need some sort of a 3D modeling software. I personally use Fusion 360 for most of my design work. It's an incredibly powerful CAD design software, and they do have free licenses out there. But because it's so powerful, it also has a very steep learning curve. So many people go with something like Tinkercad, which is much simpler to use and probably a really good choice if you've never worked in 3D modeling before. Now, if you want to do more exotic designs that involve like complex organic type designs, then you'd probably be better suited with something like Meshmixer, or if you want to shell out the money, something like ZBrush. You can also download pre-made designs from many sites such as Thingiverse, TurboSquid, Umagine, or many of the other 3D printing sites, both free and paid. Now, once you have your model downloaded and generated and saved as an STL file, which is just a 3D model design file, you'll need to have what is called a slicing software. There are several flavors of slicing software, but two primary ones you're going to hear about the most are Cura, which is a free slicer, and Simplify 3D, which you do have to pay for. Many printers come with Cura already on the SD card that ships with the printer, since it is free. Now, I personally find that paying for Simplify 3D is worth the cost, but everybody has their own preference on this. And the job of the slicer is simply to slice the model and then generate the G-code for your printer. Slicing the model means it's generating all the commands needed for the printer head movement, the bed and axis movements, and the speed that it prints, along with all the extruder commands to control filament flow and, everything that your printer actually does when it's printing. And it does this for each layer for the entire print. And the code that's generated is called the G-code, because the extension on it is .G-code. So let's look a little closer at what you typically modify in the slicer for each print. Now, like I said, I am going to be using Simplify 3D here, but Cura also has many of the same things, although they may have some different names to them. So first off is nozzle and print temperature. Now, each spool of filament typically comes with a suggested print temperature, and you'll find that many of them say something like 190°C to 210°C or 200 to 230 or whatever. But typically, with most PLA, the ideal print temperature is going to range somewhere between 195 degrees and 200 degrees Celsius. And let's see, next. Okay, now we've got the print speed. This is how fast your printer will be laying down the filament onto your print. Most people refer to these values in millimeters per second, like 60 millimeters per second, but your slicer might default the display in millimeters per minute. So 60 millimeters per second would translate into 3600 millimeters per minute. And 60 millimeters per second is kind of the ideal setting, but just keep that in mind when you're setting these parameters. Now, the primary layer height is another value you need to be aware of. Most people who print with 0.4 millimeter nozzle typically print with a layer height of 0.2 millimeter. This gives fine enough layers and detail to get excellent results for the majority of your printing. Top solid layers and bottom solid layers are how many layers that are solid on the top and the bottom of the print. Pretty self-explanatory. Perimeters are how many passes of the filament comprise the outside or shell of your print. Think of it kind of like walls with multiple layers of sheetrock on top of each other. Therefore, the more layers, you're going to have stronger walls. Usually you'll have this set at 2 or 3 perimeters. Now, a skirt or a brim is a layer of filament that's put down usually on just the first layer, and they're typically a few millimeters away on the outside of your print, and they kind of act like a primer before you actually start your print to make sure the filament is flowing properly. They can also be directly attached to your print if you set it at 0 millimeter distance, and this actually will help you get stability, which can be broken off later. It kind of acts as a stabilizer for tall prints. But if you want real good stabilization, then you probably want to use a raft, which is a set of layers that goes underneath your print in order to give better adhesion. And it's designed to easily pull off your print once it's completed. These are great for prints that have just a few contact points or they're really tall, and you don't want your print to move or fall over during the printing process. Now, infill is what the slicing software puts inside of your print to give it more rigidity, or if you have surfaces that go beyond 60-degree angle inwards on your print. You can choose the density of your infill based on a percentage value, where 0 is completely hollow and 100% is completely solid. Usually around 20% or so is ideal for most prints, and there are several patterns you can choose from, and they each have distinct advantages and disadvantages, but the majority of people either print using the rectilinear or the fast honeycomb. Now, support is for overhangs. Most printers, that includes anything beyond the say 60 degrees, or parts of the print that would otherwise start in mid-air, which you can't do on the outside of your prints. Think of supports as kind of like scaffolding, and it is designed to easily break away once the print is completed. And if you're lucky enough to have a dual filament printer, you could even get specialized filament that's designed to dissolve in water once the print is completed, so you don't have to actually break the supports away. Now, the extruder setting is where you make sure your nozzle diameter is set properly, and typically it's going to be 0.4 millimeters. I also want to point out retraction distance. So this is how many millimeters the filament is pulled back up when the hot end needs to make a movement that doesn't require filament actually being laid down. Say it needs to skip to the other side of the print and start somewhere else. It pulls the filament back up a few millimeters so that it does not ooze out as it's going across that non-printed area. One more thing that I want to mention is spiral or vase mode. You're going to hear this a lot in 3D printing, and it's good to know what it is. I mean, this setting, it basically creates a print out of one continuous line of print with no stopping until it's finished. You can have a bottom layer and a top layer if you need to, but the perimeter or wall will just be one line thick. And you won't have any infill or supports when doing these types of prints, but you can have a raft if you need to have a good foundation. It's great for doing really fast prints and using the least amount of filament. So these are a few of the very basic settings of a slicer that you should get familiar with first. Now, there are many more controls you can modify as you gain knowledge and experience, but get these concepts first and then move on. Once you're confident in all of your process settings, then you can generate the file for preview. This lets you see how your print will actually build, and you can actually kind of play it back virtually. This view is helpful for seeing if you're going to have an issue with overhangs or infill. Once you're complete, you just save the file to disk or an SD card, and the G-code file is created. Then you send your G-code to the printer by, putting it on your SD card and popping your SD card into the printer and initiating the print. And now you're printing. I would advise that if you have a heated bed, that you wait until your print surface is completely cooled down before trying to remove your print. It can be really difficult to pull it off when the bed's hot because it's designed to make it stick. So I hope you found this helpful if you're just getting into 3D printing. And keep in mind that there are literally thousands and thousands of YouTube tutorials and websites out there that get very deep into advanced topics and provide a lot of clarity on general settings for printing. But this should give you the knowledge you need to get started in 3D printing and with the software involved. Now, if you feel like you're ready to get into 3D printing and you're ready to buy a printer, I do have some links down in the description below to GearBest for some discounted prices on some of my favorite printers, including the Ender 2 and the Ender 3, which would be my recommendations if you're buying your first printer especially. Again, if y'all like these videos, please give it a thumbs up and hit the subscribe button. And if you want to get notifications, click the little bell icon. And feel free to leave comments below. I'm happy to answer any questions that I can. Remember, it doesn't matter what you're making, as long as you're making matter. I'm Jason, and I'll catch y'all next time.